Cool. Then I'll share my screen. Try not to share Slack or anything else again, or other things you shouldn't see. All right. Well, before we continue, we last left off sort of just talking about inheritance and why it's useful, sort of how it works, how this superclass works. And up until this point, we've discussed basic inherit from a single other class inheritance. And I just want to go over that for a second to see how people feel about that. Because as far as I'm concerned, that's what inheritance is. Everything from here on out is basically, here's a feature that you technically have access to in Python. And if you really know what you're doing, you can use it. But very intelligent people have learned over time that this is a great way to shoot yourself in the foot. So as far as I'm concerned, like, stay away from multiple inheritance, but we will teach it and talk about it anyways. But yeah, how about any questions or feedback, anything to say about single inheritance?
I dig it.
Okay, we dig it. Cool. Yeah, well, if you feel solid about single inheritance and the basic idea, we can move on to talking about multiple inheritance. So yeah, the examples we've seen so far are all something like cat inheriting from animal, dog inheriting from animal. And cat and dog, that's multiple classes, but the idea is no matter how many subclasses you have, they're all inheriting from a single parent class. And you might even have a hierarchy where you say, dog inherits from canine and canine inherits from whatever goes on top of that, but animal at some point, or mammal, and then that inherits from animal. But still, that's still single inheritance. It's just that each one is inheriting from a parent, and that parent inherits from a parent. But multiple inheritance is actually a new idea that looks like so on the right here. So first we have a person. This is just a regular class which doesn't inherit at all. It has a name and a job as instance variables, and then we have this function work that does something with it. And so here we are creating a person, and he does work. These are just to make it seem nicer when we print out the whole thing. And then we have another class that, again, doesn't inherit from anything. It's called a computer. It takes a number of cores, and it supports a function called compute, which will print pi to a certain number of decimal places. And we created, we're just going to create one of those. But then we're creating this idea of a cyborg. And a cyborg is not just, a specific kind of person or a specific kind of computer. A cyborg is both a person and a computer. So first, in our init function, we want to initialize both the person and the computer part of it. And we're able to do that by saying person and computer. But note, we can't use super anymore because super assumes you have a single parent, and we don't have that anymore. So that's not an option, but not a big deal. This is more or less, equivalent to super. I don't even know why super really exists if we do have access to this as a feature. But yeah, this is going to init our person and computer parts so that the self of our cyborg should contain both the name and job of a person and also the number of cores of a computer. And then we have this function called work, which you'll see is overriding a function on person. Well, what we do in it is we say, print that this person with a name, only a person has a name, has the strength of a number of cores, only a computer has a number of cores. And then for the number of cores, we're going to call work, but not this work, but rather the work that is on the person. So right here, person.work, we're going to call that work. So just like calling super.work, but we're explicitly saying, well, we're talking about the person right now. And then finally, we'll call something specifically on computer. And you'll note that you actually do have to pass self here when it comes to calling person.work. We can't just say super.work because it's sort of like we're accessing it as if it's not just an instance variable, but a class variable, and then we're explicitly passing what instance it refers to. which is a little odd, but also you won't see this pattern a lot because you're not going to do this a lot. But anyways, the final result of this is that if I run this, I see some output, and so you see above, first we had this, Ben is a person and Ben is working hard as a teacher. Am I? And then finally we have, I am. We have a computer called Chappie, and it does this computing pi to 4 decimal places thing. And then finally we have our cyborg named Terminator, and it does all of this. And it's able to do all this because it has access to everything, to all the instance variables and all the methods of both a person and a computer. So it seems like a great pattern, in my opinion, on the surface, and that we're, why not just keep doing this? And especially if you're not worrying about something having an init, it's really easy to do what in Python is called a mix-in. So I could just say something like, what's something fun? Okay, yeah, so be backable. Obviously a very weird name, but you'll see this a lot where when something is a mix-in or what we call an interface, it's blank a bull. So like, let's say you have like an animal class, you might not want to have a specific class called flying animal, which is more specific than an animal, or something like that. Or like, let's say you had like a bird class, not all birds fly. So instead, basically you would have a bird class, and then you would have, maybe you'd have a class called like geese, and it would have bird, but it would also have a flyable mix-in. And then a different bird, like a penguin, would just have bird. It wouldn't have flyable. And all be backable is going to be, we'll say we have this class called be backable, and not going to do anything with a init. I'm just going to have what do they call that? Yeah, say catchphrase. I didn't even do that right, but right. It's gonna, because it is a class, we still have to give itself, but say catchphrase, and its catchphrase will be I'll be back. And then just by adding it in like this, I don't have to do anything, especially because it's not a variable or anything. I don't need to call a init on it. I just automatically, I believe, get this say catchphrase for free. We'll actually see if this works or not. So down here, I should be able to say Terminator dot say catchphrase. And if I run this, it says I'll be back. So a mix-in is an easy way to add functionality little by little to a given class by just breaking it down into like each mix-in type class just represents 1 or 2 functions, and you add the ability to call those functions just by adding it as another thing it inherits from. In a second, we'll see why all forms of multiple inheritance, including mix-ins, like basically it's a very powerful thing. You can do a lot with it, but as things grow, it's generally seen to be a bad pattern for a couple of reasons. We'll get into that a little, but how do we feel about this multiple inheritance thing in general?
So the difference with mix-ins is it's like a class that cannot be initiated, or what's called instantiated. You can't make a be backable thing.
Exactly. Yeah, I believe so. So I don't know if there's a technical definition, because mix-ins are not an idea that's sort of built into Python. It's just a pattern people figured out. But if I tried to say, example equals be backable, this is going to break or not. I would imagine it would break because there's no init and it doesn't inherit from anything. Maybe it's because I'm not trying to do anything with example, but honestly, this doesn't make sense to me. Did I just not save? I think I did save.
See if it can do a catchphrase. If example dot say catchphrase.
Example dot what?
Example dot save catchphrase, or say catchphrase.
Oh, right, exactly right. Good point. So let's try that. Yeah, no, it works perfectly fine. Okay, that's good to know that if you don't have any instance variables and you're not referencing self anywhere, that you could do that. That's not going to break. So it works perfectly fine on its own. Maybe you would say it shouldn't, but that's sort of the programmer's responsibility / discretion to say, well, we don't make be backable instances. Rather, it's only there to be used in this like mixin type of way. But as it turns out, you can create one. And there is no, a mixin is not a real, it's not really, it's no different than regular multiple inheritance. It's just sort of a way of saying, well, because we don't create an init, we never have to, you know, write the init in there. And so it's a really easy way of just adding functionality without having to think about it, because all I did was add it in here, and I can add it or take it out, and I don't have to change the body at all. But if I add it in, suddenly I have this extra ability. And I believe because of the nature of duck typing in Python, this extra ability could even be like, even though be backable has no idea that it's going to be used in the context of, you know, a person and a computer, because it has access to self, I should be able to say something like self.number of cores. So let's try that. I'll just say, or is it F, right? I'll be back. And then I should be able to say self dot, and you'll see it's not able to autocomplete it. But I believe this should work because the self here, when we call terminator.say catchphrase, terminator will be the self. And so it will have access to a self with a number of cores. So I believe this will work. It does work, yeah. So you can already kind of see why a mixin is both powerful and dangerous, because it was really easy to get some extra behavior out of it. But also at this point, I'm saying like, hey, well, I want to get some extra behavior that's not self-contained. I want be backable to add functionality that only works if it's part of a multiple inheritance package that also includes this thing called computer. And so that is cool that it can do that. But also, if you're in a situation where, like, you know, there's hundreds of classes, and the real issue is that as a project grows, you are not the only one working on that project, and there's actually nobody on the team that fully understands the project, that has read every line of code and understands it. So you run into these situations where someone could come up with something like this and say, hey, that's really quick and snappy and it gets the job done. And then later someone tries to use it in a situation that doesn't work. And unless it has really good documentation or something like that, there's no way that the language can tell you, hey, that's a bad idea, or that's not going to work. And sometimes it'll, you know, something like this, it might not break right away. It'll only break in that specific case where you're trying to access something you don't have access to. And that can be a hard bug to find, and it might make its way all the way to production. So yeah, it's like, these are very much the sort of patterns where you could see the benefit, but immediately you could see why it's a bad idea too. And it's not a bad idea when you're in control of everything. It's only a bad idea when the team's big enough that you don't know how something's going to be used by someone else or things like that. Yeah.
Before you put be backable in there, I'm still confused as to why you initted the cyborg. If you didn't do the initiation, wouldn't it just inherit everything from those two anyway, and then the code below would work whether you initted it or not?
I don't know, actually. It's a good question. We can try it. As in, if I take out the init entirely, is that what you're recommending first? Like, I take out the init entirely, because why am I initializing these two things? Like,
yeah,
I'm initializing these two things because I thought in my mind it's necessary to do that in order for self to have those variables on it. But that might not be the case. It could be that it's enough just to do this, that when you create, I mean, I think what's going to happen here first is that when I try and create a cyborg, it's going to say, it's going to complain a little bit about the fact that basically what is this the initializer for? So person init takes 3 positional arguments, but 4 were given. Okay, so it seems like it's looking for something that takes 2 arguments besides self. And I see person and computer, and person comes first. So it looks like it's just going to default to taking person, which has a name and a job. But yeah, let's try that. We say, okay, a terminator is an Arnold cyborg, so we're just giving it that person thing. And then where does it mess up? It messes up when it hits this line and it expects a number of cores, because our person initializer that it inherited doesn't have that idea. So, I mean, there probably are other ways, but
Can you just initialize computer.init instead of person and see if it will inherit person?
Are you saying switch the order of these?
No, I'm just saying now just use the computer.init in the init function and not use person.init.
Okay. Yeah, I think the problem there is it's never going, it's not now, because I'm defining init, it's no longer implicitly inheriting persons. So now it's going to say, okay, you gave me an Arnold, a Terminator, and an 8, and then I mean, yeah, let's try it. That is one way to find out. You try it. And it doesn't like you because it's saying a cyborg does not have a name. Because we never did anything with name or job. Yeah, I mean, we could always get away with just, explicitly saying something like self.name equals name, self.job equals job, self.number of cores equals number of cores. But this is the more standard pattern where you just you initialize that internal thing, and that makes sure that the self you are referring to, I believe all this is doing, just think of this as a function. We're going to look at person.init. We're passing in self, and self here refers to our new cyborg instance. So basically we're just passing in self, adding these two things to it, and then doing the same thing here where we pass in self and add number of cores to it. So this is essentially just doing the job of taking this, which is going to be our cyborg instance, adding name and job to it, taking this, adding number of cores to it. It might do more, and that's why we want to run it, because maybe it does some important setup, but right now that is all it's doing.
It seems like, I bet you wouldn't have to define the init in Cyborg if both of those person and computer took the exact same number of arguments with the exact same name. It seems like you have to define that init just to make sure that the initial arguments that you're passing for Cyborg are 3. So you have to define the init to make sure the right argument goes to the right init. That's all it is. It's like, it's like sending the right arguments to the right place.
If I take this out, you're saying if I have self, name, job, and number of cores.
Yeah, put number of cores, but that's going to have to also match computer as well.
Yes, I'll do this, you're saying?
Yeah. Yeah, and even if you don't do anything with it, I bet you it would run.
I don't think it's going to work, because I think it's just going to take one of these as its init. I guess it seemed like it takes the first one, but it's just going to take one of them. And one of them is not doing anything with some of those other variables. So I think it's still going to blow up and say, I don't know what you're talking about when it comes to, oh, well, I still need to, okay, person. That's not really an important part of it. We don't need that anymore. Yes, Cyborg has no attribute number of cores. I think because what's happening is that Cyborg has no init, so it's inheriting its init apparently from person first.
Because that's the first one that's
uses name and job. It's not using number of cores, or it's not setting number of cores anywhere. And really, I mean, that leaving out the init thing is sort of like a nice shorthand when nothing has changed. But it is a much better pattern in general to be explicit, kind of always. And in this case, we're just saying, well, the way init works is it essentially calls super on the person part of it, calls super on the computer part of it. And as it turns out, that's it. There's nothing additional to a cyborg besides those two things. But yeah, I mean, I
just tested it, and then you can actually remove the person and computer from the top. No. You can keep the init, and then And then you can actually just get rid of the parentheses of person and computer and just define cyborg as its own class. And because you're already pulling in person and computer from there, it actually still runs fine.
I think that's just because of, yeah, these things. Let me quickly change those. Okay, yeah, good to know. I'm sure there is a reason that we do inherit from multiple things versus doing this. I think, yeah, I mean, it's a good point. Python seems to support multiple ways of doing this stuff, and this is almost a good lead into what we're going to talk about next, just making sure we are going to talk about that next. Yeah, exactly. Yeah, because this is getting us closer to this idea of composition versus inheritance, as in cyborg initially was inheriting from person and computer. But as you're saying, that's kind of unnecessary. I mean, the composition approach, in short, we will discuss it in a second, but the composition approach is basically, instead of having a cyborg be a person and a computer, instead it simply contains a person and a computer. So you'd have something like self.person equals that, self.computer equals that. And you wouldn't say the init part of it, because instead of doing it in that way, we're just going to treat it like a normal, constructor. And then every time we needed the name, for example, we would just say self.person.name, self.computer.number of cores. What else do we have here? We don't have access to person like this, but we do have access to self.person, and we don't have to call self on it anymore like that. Again, we don't have self.number of cores, but we do have self.computer.number of cores. And we're almost done, right? We want self.computer.compute and take out that self. And are we almost there? Does this work now? This does work, yeah. So basically, this would be the composition as opposed to the inheritance approach to this. And I like this a lot more, because you could see how, as the number of multiple inheritance things you inherit from grows, gets pretty confusing. And we'll see in this example, we have like things can overlap, things can get weird, and you just completely avoid that problem with composition. And the only price you pay, which is barely a price, is that instead of being able to say self.name, so cyborg automatically has a name, instead you say, okay, well, cyborg has this thing inside of it called a person that has a name. And that can get annoying if something is really long, that you end up saying self.this. We would call that like field drilling or prop drilling, because the idea is you have to drill in and in and in and in order to get to the thing you actually care about. But in my opinion, this is a much more sustainable pattern. And also importantly, most languages do not support multiple inheritance. So this would be the go-to way that you would say, a cyborg supports kind of the behavior of multiple things. But yeah, if we have more questions about this, we can stick on it for a second. But the next natural point that we're getting to is this question of composition versus inheritance. Okay, so it looks like we're gonna start.
I have one more quick question from before, if you could bring it back. Could you abstract it further by saying, like, I don't know, a person equals self.person? And then you could just not have to drill in, like you said, for like self.person.name, you just put person.name because you've already reassigned person equals self.person.
Yeah, absolutely. So you're saying just have, like, let's say that you're never going to be accessing the whole person. You just want its name, right?
Right.
So we create, that's totally reasonable, right? You create a person. Yeah, I mean, honestly, yeah, right. You could just say, you could create a person and then immediately take off its name and save it in something called name. Again, you could have the number of cores, create a computer.
Right. Because then you don't have to drill in later on, like down there.
Yeah, the problem with that is that we no longer have access to things like this. but you could have both, as in you could have
Sure.
this, or sorry, you could have this,
Mhm.
and then at the bottom of it, you could say, well, actually, I really care that I just have direct access to the name. So, and I know that that's not gonna, that there's like, you see how we're getting into this issue of like, this sort of requires you to know a fair amount, where like, maybe the nature of a person class is that over time, this internal name instance variable updates. Could be, you know, could be that when you run the job, like basically when you run, you know, person.work, for whatever reason, that updates the name. That could be an actual thing that's supported in person, assuming you have no idea what that class works like. And then this would be a mistake, because this would say, okay, self.name equals exactly what person's name looks like initially, but if it were to change, this would not get updated. So it's kind of tricky in that, like, you're right. This is a good approach when you know name's not going to change beyond the initial thing. There's also another version of like, you know, let's say you knew name did change. Well, what if person didn't just have a name, but it had a getter called getName? And then you could just say, okay, well, self has something called getName now. And because it's referencing the same function, if when we call getName will call the right function on person. And then it would have the correctly updated one or whatever. But yeah, it's what we're getting at here, like this is something that's hard for me. It's honestly legitimately hard for me to teach object-oriented programming, because we're never going to get to it in this course, but there's sort of these different paradigms in programming. And object-oriented programming would be considered a paradigm. It's essentially an approach to programming that preferences certain ways of doing things. And there's another approach that's called functional. And I happen to really prefer the functional approach. And 90% of the functional approach is just saying, look what's wrong with object-oriented programming. Look how it doesn't actually solve the problem. So my personal issue with object-oriented programming, which, you know, I'm not the only one who said this, but it actually does not solve any problems of complexity. It's just very good at hiding complexity. So it seems like you can just say, oh, well, a cyborg is a person and a computer, and then you're done. But not really, because your cyborg has an internal person and an internal computer. And if your person changes in certain ways, that could affect how your cyborg works, where now you have to adjust your cyborg to account for the fact that a person is different now. And it's not object hierarchies and classes are really great at building up these hierarchies, but you sort of there's a lot of these like silly quotes in programming, and there's a famous one about the perils of object-oriented programming, and it goes with object-oriented programming, you have like basically you have a jungle class, and you want to call jungle.getBanana, and it does return a banana to you, but it turns out there's a gorilla holding that banana, and you didn't account for that, but now you have a gorilla too, and what are you going to do? So it's not as clean as you often want it to be. We would call that in functional programming, we refer to this entire concept of unintended consequences as side effects. So object-oriented programming tends to result in a lot of side effects. And those side effects are the source of most bugs. Sorry, someone said something?
Yeah, how does functional programming, I guess, solve that? I mean, if you could say it in like maybe like a one-liner, just simplify, like how does functional programming like address the issue that OOP?
It's a little hard to get into that right now. When we get to the React section, hopefully we'll be able to talk about this a lot more, because React follows a pretty functional approach. But the main thing is that in functional programming, you generally avoid what we call state, like the plague. So you never have, like, instead of having like a person and this person holds on to things, and when you call things, that person is updating in the background, you just kind of never deal with things that update in ways you can't see. You only deal with sort of hard values. And anytime you make an update, instead of calling something like person.work and that does something, instead person.work would be a pure function, which instead of doing something, it returns some value that represents what it did. And then the person who receives that update can say like, instead of being work, it would be something like work done. And then we would have a variable here called work done. And then at this end, we could look into work done and say, okay, this is the work that was done or that we want to get done. So now I'm going to handle that at my end, as opposed to it just sort of happens in the background. It's hard to see with the examples we have. But it's worth also pointing out that functional programming is not a silver bullet either. A lot of these things work well in some situations and not in others. And that's something that's hard to teach. It's just over time, you sort of learn, like, basically when you hit bugs, or when you hit real bugs that sort of ruin your life for a day or two, it ends up being a lesson of, oh, wow, like that seemed really good when it started out. It ended up getting really tricky by the end. And so there's this like emergent complexity, and programming tends to be the art of managing complexity, because things just get complex to the point where no one knows really what's going on by the time a project's really big. And all your tools are about sort of managing that so you can sort of know what's going on. Hope that's an okay answer.
Gotcha. Yeah. Thanks.
Cool. Yeah. But yeah, so unless we have more questions, a last 10 seconds for questions about this, we're going to move on to composition versus inheritance. And just clarify, we have until what time for this lecture? We have another, what, another hour or another like 2 hours?
Another hour.
Okay, good. Yeah, because I was going to say we don't have enough to fill 2 hours, but you guys are probably happy about that too. Right. So composition versus inheritance. This is really more of a philosophical thing. This question of composition versus inheritance came out of the fact that people would create these big hierarchies of inheritance, and they would find that they'd have to change things down the line, and that the nature of inheritance, it's what we would call tightly coupled. So when a dog is an animal, that's sort of a tight coupling where a dog automatically inherits everything an animal can do. And so when you make changes to animal, that's going to affect dog in a way that's harder to sort of like, it just becomes harder and harder if you made bad decisions. Like a dog is an animal, so that works. But if you said that a dog was a walkable, that would work until suddenly you had to account for a dog that couldn't walk. And then you'd have to do some real tricky stuff to try and say, okay, well, a dog is a walkable, but this is a dog that is a walkable that we are specially modifying so that it knows it somehow can't walk. And basically there's this inherent problem with inheritance where unless it really is an A is a B relationship, it's going to cause you problems down the line when it's no longer true that it has that relationship. So here's just an example of what might be a good use of that sort of inheritance. Like, let's say you work for Carvana or something, you have to have a list of all the cars, and maybe you want to make it easy for sorting purposes, just to say, hey, we only want the 4-door sedans. That's all we're looking for right now. So it kind of makes sense that you would say like, okay, well, I have this specific thing called, which I'm going to define as, I guess I'll write it here. Let's just say we had a class called 4-door sedan. It would probably take arguments because this wouldn't be obvious that these are true things, or just that these wouldn't be built in. But basically, this is a specific 4-door sedan that has these qualities that, our constructor or our initializer knows about. And then if we looked into the, somewhere here, we have something called class 4-door sedan. And then if we dug in there, we would find that there's a class called car that it inherits from. So actually 4-door sedan inherits from car. And then we find out that car actually inherits from vehicle, because Carvana is, not just dealing with, regular cars anymore, like passenger vehicles. They're also dealing with things like trucks and who knows, bicycles, anything. So we have a class called vehicle. And maybe that's where it ends, that, a vehicle kind of represents our top level. But all along the way, this made sense in that all 4-door sedans are cars. All cars are vehicles. And as long as these things are defined in a reasonable way, vehicle might have this function called move on it. And then car could utilize that move function with something called drive. And 4-door sedan would inherit that drive function, but maybe it would have an additional thing like open my 4 doors because I have exactly 4 doors. And that is a good use of inheritance. But it's not the only way we do use inheritance. And let's see where that blows up for us. Oh, so I whipped past this really fast, but this is my example of why most languages don't support multiple inheritance. So this will be helpful for us in understanding why composition is a better model. So here, this is a contrived example, but basically I have this class called mother. As you see, all my examples are exactly about myself. But I have this class called mother with a first and last name, just built, hard coded. Same with this father class. And then a child, I mean, this almost seems like it should make sense, right? A child inherits from its mother and father. And so I'm calling mother and father here like we did in the original thing. And then I'm setting my first name here. And then I have this function called print first name. And then when I create a child object, I'm going to try and print the first name, right? So what happens? Oh yeah, it prints Benjamin Walensky. Well, that's actually not my name. My name is Benjamin Cohen. But why did that happen? That happened because when we dig into this stuff, I'm inheriting last name, and I'm kind of relying on that. I want to inherit last name. I don't want to have to think about how I have my own last name. That's just inherited. But I'm not being very explicit about it. So as it turns out, I inherited my father's first and last name. And then I overwrote it with my mother's first and last name. And then I overwrote the first name with myself, but I'm left with my mother's last name. And of course, if I just swap this and I happen to init my mother first and my father second, now I have the right name. Even though it seems small, in my opinion, this is a great reason why multiple inheritance is terrible, because the order in which you execute things that seemingly, there's nothing about this init that tells you, oh, it conflicts with father in some important way. There's something really wrong about that, because an important detail is kind of hidden from you. And then merely the order in which you initialize things changes, the ultimate behavior. And imagine this wasn't just mother, father, but this was like, a billion things that represented who I was. And these various init methods might, conflict in various ways. And it's not very transparent what's happening or when something even goes wrong. But yeah, how could we, let me open that back up. How could we theoretically fix that? Sorry, I gotta move this out of the way. How could we theoretically fix that? Well, one way is with just the idea of composition. So when we're dealing with inheritance, we're modeling something that where we say, car is a vehicle, or 4-door sedan is a car. And if that's true, that's going to be a good way of modeling that. But composition is for the has a relationship. So in reality, it never made sense in my initial example where, child is a mother and a father. Not exactly, right? That doesn't really model what that is. Rather, a child has a mother and has a father. And so we might better represent that with something like this, where I have this mother class and this father class, and then composition is just, okay, I don't inherit anything, but I can set my own first name if I want to. And then I have this internal father and mother. And notice I didn't overwrite anything. So if I want to access self.father.first name, I know my father's first name. It doesn't have to conflict with my own first name, because me being born doesn't overwrite my father's first name. It just, I wasn't modeling it right in the first place. And now in this case, I can be very explicit where I say, okay, my first name is my first name. What's my last name? What's my father's last name? And you might even say, well, actually, maybe you want to hold on to your father and mother, but as someone mentioned before, maybe I want to hold on to my father and mother, but I also want to be explicit about the fact that, okay, well, I do have a last name, and that last name is going to be my father's last name. I know enough about this last name business that it's not going to change on me. If I set it to this initially, it will forever be that. And this works like you would expect now, and in my opinion, is much cleaner and nicer and scales up a lot better in that a child doesn't just have a father and a mother, it could have a sister and a brother and anything. It could have anything. And holding on to a copy of or a reference to something you're related to makes a lot more sense most of the time than inheritance. So yeah, how do we feel about this idea of composition? Do we understand what composition is? Do we like it? Or do we feel like it's not as good as inheritance in some way?
I have a question. So I know you're calling the class father, calling the class mother, but or storing those in the variables, but what's the difference, or performance-wise, why don't we just use a dict for this scenario? I guess overall, I understand that maybe you want certain methods on father and mother, but couldn't you put those in a dictionary as well?
Meaning like not use an object at all, but just have a dictionary that looks like, you know, that has something called father on it, mother on it, first name, last name, right?
Yeah, or like a father dictionary and a mother dictionary.
Within this class or not in a class world at all? Like, are you just saying like, why not have something called father that looks like first, you know?
Yeah, exactly. Yeah.
Yeah, no, that makes a lot of sense what you're saying. This is a pretty contrived example. I would say think of a class like a specific dictionary. And if you don't need any methods that uniquely work on that dictionary, a dictionary is preferable to a class. It's only once you have specific kind of methods that it makes sense. So you are right that a dictionary makes more sense. And the truth is, none of this really makes sense in that it makes a lot more sense to have a class called person, and a person has a first and last name, and then a specific person, you could say, holds on to a mother and a father of type person. And then that person maybe could support things like print full name. So this is a pretty contrived example, but the point I want to leave you with is that, well, besides that, you know, composition is a better approach most of the time than multiple inheritance. Basically, a dictionary is a good solution to lots and lots of things. And if that's all you need, that's great. Don't use classes just because you're like, oh, it's a fancier tool or something. A dictionary is basically a simple class that you don't have to get too involved in defining. But like in that first example above, a dictionary as an idea kind of breaks down over time, and that once you want functionality, it's kind of nicer to have a class. Once you want methods, it's nicer to have a class. But if it's just a collection of data like this kind of represents, yeah, I would say you just want to use regular dictionaries.
Cool. Thank you.
Cool. So yeah, that's the basics of this idea of inheritance. Modern wisdom is basically, you know, for people who do object-oriented programming all the time, like Python, it's an option. But if you're in a language like Java, everything is object-oriented programming. You can't get away from it. It's the core idea. And in there, certain, you know, ideas have evolved, and people basically have this phrase now where they say prefer composition over inheritance. Doesn't mean never use inheritance, but it basically means start by modeling your thing as composition, in which you say, okay, a child has a father and a mother. But just as well, you could say that a four-door sedan has a car, and that you can get away with that for a pretty long time, where you just say, okay, well, my four-door sedan has an internal thing called car. And anytime I need things that are specific to the car, I just say, you know, self.car.something. And that works. And it's only maybe after a little bit of time that you could say, oh, well, I'm realizing that, you know, it's not that a four-door sedan has a car, rather it is a car. And so maybe it is worth doing this in the inheritance way, and that'll, buy me a little, it'll make things a little nicer syntax wise, but I won't pay a cost for it because it is the correct relationship to model. But yeah, that's the core of this idea. Not even prefer composition over inheritance as much as understand what the relationship you were trying to model is, and only use inheritance if it really is a blank relationship. And that's kind of rare, actually. That's going to happen sometimes, but more often it's not. More often you're going to, things are going to contain other things. So if we feel good on this, I have a few examples I wanted to talk about where it's just like, we're not going to flesh it all out, but it's just sort of an exercise in saying, like, how might you break this idea down into, a set of classes? And then we'll probably be done a solid half hour early so we can discuss things more or give you that time back. Yeah, I mean, there's certain things I think that might be interesting to talk about. Like, you've probably never heard of this, but there's something called UML or UML diagrams, which stands for Universal Modeling Language diagrams. And it's basically a way of, if you are dealing with lots of objects, or you're dealing with basically, if you're trying to model everything as objects, a UML diagram is a language agnostic. You guys shouldn't see the garbage I'm looking at. You guys, yeah, so a UML diagram is a way of modeling how you might like lay it all out. And so that's an idea that I feel like it's worth looking at, but also it's unlikely you'll encounter it in the real world anymore. But it's sort of a nice thing of, oh, wow, this actually is like a way of creating them, which is pretty cool. How do I move around?
Looks like a schema.
Exactly, right. That's exactly what it is. So it's a way of saying, like, okay, well, I mean, basically these different lines have different meanings. So from what I understand, this, the empty, the white triangle line means, not triangle. Yeah. Basically, the white arrow towards something means inheritance. So this is saying, okay, well, a window has these, variables and these methods, and a wall has these variables, and both of them inherit from structure. And then this relationship, this black diamond, is saying composition, has a. And then this number here, 0 ... star, is saying room has a structure, but room has, 0 to many structures. And then similarly, a room has 0 to many furnitures, and couch inherits from furniture. And then finally, I think this arrow would be like a mixin or an interface, like I was saying, where we're saying a room is drawable, but it's not room is a drawable. Rather, room has this additional functionality called drawable, where we're just adding these two functions to it, redraw and hide, that it otherwise wouldn't have access to. So that's essentially where I got the idea below, but it might be actually fun to try and do it in here, as long as I can figure out the basics of this thing. Like, I'm just gonna delete all this, and then we're going to work in here to try and work through some of these examples. So I'm gonna close Scratchpad for now, and can even close this for now. And coming down here, I can have this thing where I say, like, okay, well, here's a domain where, let's say, I work for some gardening company, and we kind of, we have clients, and we keep track of the clients' gardens. So how might I do that? Like, maybe I'm gonna grab this thing here where I say, like, okay, well, I'm gonna call this class client, right? Well, what does a client have? Like, what might make sense for a client to hold on to? And we could literally copy it from here. But this was just me like kind of thinking like, okay, well, what might it look like? Like, so we could say, okay, we have a client and I didn't even give it any functionality. I just said, okay, clients have something called gardens. Don't make me sign up. Clients have gardens, and I'm just going to write this to say, okay, well, it has type of, you know, an array of gardens. I haven't even defined what a garden is yet, but we're going to hold on to gardens. And then maybe we also have this thing called, you know, payment info, and that's going to have a type of, you know, payment info, but I haven't even defined what that might look like. And we'll ignore the method stuff for now, but then I could say like, okay, well, what is a garden? I have multiple gardens, right? Well, that's this relationship where I can say, okay, well, a client has multiple gardens. If I wanted to be really explicit, I would like, you know, I wonder if this allows me something where I can, yeah, so if I want to be really explicit, I say like a client has, you know, maybe you can't make a client without at least one garden. So a client has one-to-many gardens. And then what is a garden? Well, a garden has, you know, an address at the very least. Let's just say an address is represented by a string, but in reality, it would probably be more. It would have like, you know, it would have some representation that would be good for like Google Maps to say like, oh, we know exactly where this location is. And then gardens also have garden items, and those are an array of garden items. So then we can do that relationship again. I actually want to, is there a way to nicely connect this? Yeah, there we go. Oh, now it moves around, great. So I can do that again where I say, okay, we're dealing with, which one does it want? I never know. So gardens have multiple garden items. Rather, it has something of type, right? It's a list of garden item. And we're not even going to define what is unique to a garden item, but I could say like, well, actually, you know, a couple things inherit from garden item. So there's one type of garden item called grass, and maybe grass includes some kind of, you know, type. There's going to be a string, and then maybe also there's a method on there because we haven't showed that. There's a method called mow, where, you know, it mows the grass and maybe it returns a Boolean to tell you whether it was successful or not, or something like that. As you can see, I could also have, you know, this gets like bigger and bigger, but this is sort of like a nice exercise if you want to. You probably won't do this anytime soon, but if you want to model sort of like how something works, you're generally going to start with some like, you know, parent class, and it's going to have these ideas. And in here I have like, you know, oops, we connect that. Sorry, I don't want that one to be grass, but rather I want this one to be called, what was it? Tree. And tree is a garden item, but actually even, you know, we can have a hierarchy here where I could say, well, actually, you know, there's a couple types of trees and I want to, for whatever reason, represent those as their own classes. So I would say, you know, maple is a tree. And similarly, what was it? Oak is a tree. And you can see how pretty quickly you could build like a whole representation of your business or something. And also, this could grow and grow and grow where like, this would be useful where, you know, even if you're not a programmer, you're like a business person, or if you are a programmer, you just don't, what's the word? You can't look through all the code. This is a nice way of saying like, this represents our entire, you know, object model for this, this specific domain. Okay, so I want to stop for a second. And how do we feel about this? I don't actually talk about UML anywhere in the docs. I just wanted to like, it is a, an interesting way of thinking about this stuff. And really, these are the only two sorts of relationships you care about. There are more, but a lot of them only make sense in a language like Java, which has very specific ideas for other things like interfaces. But yeah, how do we feel about this? Like, can you see how this would be useful, and how, like, clients do have multiple gardens, but I could also have a branch off here that's like, well, it holds on to payment info, and you can start adding trees, types of trees.
I had a question. You said that you probably wouldn't see this anymore. I'm just curious, is there like something else that I guess development teams use to like architect, or model things, or is it
Yeah.
like they just don't use them?
Yeah, no, it's a good question. You might see it still. It's really big in the Java world. I don't think it's particularly big in the Python world. It's not particularly big in the world of web development. It's really, basically, this is almost like a business tool more than it is like a programmer's tool. So some places swear by this sort of thing. And they basically, before they write any code, they'll really work in the UML world and say, does this make sense? Does our model make sense? Because as you can imagine, it's way easier to modify something here than it is to, I didn't do that right, whatever I did. Okay, whatever. But the point is, it's way easier. It's way easier to do stuff in this world. I don't know what's wrong with it. It's way easier to do stuff in this world than it is in code. So it's sort of like just some people like using UML to sort of sketch out their idea, because maybe they'll catch issues with their idea, before they have to write a single line of code. I have never seen UML in the real world. I only learned about it in school. You'll sometimes see it in like, tutorials online. But really that has more to do with the fact that in the real world, even at good companies, things move fast, and people are often sloppy in a way where like a tool like this becomes out of date so quickly, people just don't use it. But it's just like, good projects have documentation. Most projects have no documentation. It doesn't mean that documentation is not an incredibly useful tool or that you won't see it in the wild. It's more just that it's one of the first things to go when people feel like, oh, we have deadlines and things have to get done. And it's not good, because it means it's going to be harder to onboard new people. It's going to be harder to just maintain a project for its lifetime. But yeah, basically, you won't see this that often, not because it's not useful or good, but because it's not necessary.
So if I was on a new team and I'm sitting here doing UML diagrams, people look at me like, what is this kid doing?
Yeah, that's a good point. If you are the new person on the team and they don't use UML diagrams, and they're like, hey, solve this problem, and you're busy making UML diagrams, I mean, honestly, you could justify to them and say, hey, we don't have any documentation. This is me documenting what I'm learning in real time. I think it's useful to save it somewhere. Like, there's an argument there. There's always an argument for creating useful documentation like this. But at the same time, you sort of, like, if you're new to a company, you sort of let whoever's more senior take the lead a little in terms of saying like, well, we don't currently do it this way. So, it's more of it would be more of an effort on your part to push them to do it. But yeah, basically, I just want you to see a UML diagram so you know that such a thing exists. The idea that you're going to be making your own anytime soon is unlikely, unless you find it to be a particularly useful like tool for sketching out your ideas. So that's the answer I have. But it's a good question in terms of whether we actually see this stuff, because that kind of comes up a lot in not just the bootcamp world, but sort of the education world in general. There often is a gap between what is taught and what they want you to know about, and what like a sort of classical version of something looks like versus what real world development looks like, which is often sloppier and just, you do like, yeah, I certainly learned that on my first job, that they want you to do something in a hacky way if it's going to be quicker and let them hit some deadline than to do it the right way. Cool. Yeah. So it's 10:30 now. as you see, I have a second example of like, a banking thing, but let's forget about UML for a second and just look at it here. As you can see, like basically I'm just saying like, hey, okay, I mean, if I'll put it somewhere where it's going to look a little nicer. Wonder why it doesn't like self there. But yeah, so basically, let's say I'm in a banking type scenario. I might, again, have a customer. Maybe that customer.
Generate monthly statement function doesn't have self, isn't calling self.
Say that one more time.
That line 9.
Yeah.
The parentheses should have self in it. That's why the self
that's
is
what you're telling me.
highlighted.
Oh, oops. That won't work. Cool. Yeah.
I noticed that because I've done it a lot.
Yeah. I forget it too, because that is sort of a unique to Python thing. Lots of languages don't have it as a first argument. Instead, they don't include it at all. And then you just have this keyword called this. We'll see that in JavaScript, and that's how Java does it. And a lot of languages do it, but that's all just syntax. There is something nice about this, like being an explicit thing. But right, yeah, so here we have a customer, some stuff it holds on to, some stuff it can do. These dots are just to say, fill in the details. And then, maybe I have this monthly statement class and I have an account, and then there's 3 types of account that, inherit from account. And yeah, I just wanted to give an example of like what these things might look like if you're trying to model some like larger problem. But that's basically it. So let's take questions now, and then when we're done, we'll just break, and then after lunch, we'll do assignments. Resources. You'll see we have this resource here, just some, article about, method resolution order. And in my opinion, this is exactly why you don't want to use multiple inheritance, because I don't want to have to learn, oh, it does it in this order versus that order. This is just showing you why this is a complicated way of doing things. Like I don't want to have a diagram like this anywhere in my mind. It should just be straight lines. And if it can't be straight lines, maybe it's not such a good pattern. But yeah, any questions on inheritance before we break for lunch and then do assignments, or are you all desperate for lunch? Let me open the chat. See, Dan still thinks OOP is kind of silly. As the instructor teaching OOP, I shouldn't say this, but as a person who likes functional programming, I agree. I don't think it buys you much. I think it's kind of annoying. And yeah, I also don't like OOP that much. So you could be open about that. There's a good point there, Daniel, about how some languages have this idea of private versus public, and the fact that you can't do that in Python or JavaScript. I think it's sort of a feature in JavaScript now. Means there's a little less power to this whole object-oriented thing. Like in object-oriented programming, sometimes people talk about encapsulation. And that's basically the idea that you can, have your class work in a certain way, and maybe it relies on all these variables that are internal to the class, but not accessible externally. And that's because in languages like Java, you have keywords like private and public, and that does not exist in Python. So anything that's an instance variable is accessible to anyone. And so it's a little less useful as a result. Okay, everyone wants food. Chase is going to eat a whole chicken live. Fun. Mason asked a good question. We're not going to get to it for a long time, but he's asking about React, whether we're going to use class components at all or just functional components and hooks. I believe at this point, we only teach the modern functional with hooks approach. Yeah, you don't. React updated itself very nicely where the class component approach, if we teach it just to say like, hey, you might see this on older projects. But you basically don't see it too much anymore. Yeah, that annoys me. Yeah. I would say my hope is that like basically I don't see myself as super great at teaching this Python stuff because it's not what I focused on in my career. But I can tell you that when we get to React, I can teach React up to date. As in, I've been a React developer for like, the last 4 years. I know React very well, and I know what people do in React today as opposed to like 2 years ago. And it bothers me that boot camps in general often are slightly outdated compared to industry, and that's somewhat unavoidable. But the good news is that I was in the industry like 3 months ago, so I can easily update any outdated curriculum we have in that world to make it good. So yeah, that's going to be exciting. I can't wait until we get to React because that's my bread and butter, and I find that fun. Cool. Yeah. So I guess we're going to break now, right?
I just got a quick question
Yeah.
about Python and functional programming. Is that like a thing? Since functional programming is a paradigm, do people like program Python functionally?
Yeah. So it's definitely a thing because the nature of most languages, including Python, is that they're going to be able to. Wait, I want to see if I can get back Scratchpad. There we go. The nature of most languages is that they're going to be able to support multiple paradigms. And there's nothing about the functional approach that requires a specific language. There are languages that are considered functional languages, like OCaml is one, or Haskell, or sorry, did you have a specific example?
Oh, I would say I think Lisp or Scala.
Exactly right. Yeah, Lisp is sort of the grandfather of all functional languages. And all of those languages, basically what makes them functional languages is that they sort of push you down that path a lot harder. But it's not that you can't do stuff in a functional way in Python. And when I say functional, I mean something as simple as basically, if I were to have some kind of I could have a class called counter. I mean, doing this in real time, I probably won't do this well, but you might have some counter class, and in it, we had something called like self.counter, and then you got to give it self, right? And then inside of there, we might have something called increment. And within there, we'll say self.counter equals self.counter -1. And then I'll just copy that. Sorry, that's not increment, that's decrement rather. So this is a classic object-oriented approach to this. And a functional approach might have something more like I have, a variable, or sorry, I have something called counter that I'm going to set to 0, and my goal is basically to never change what you can't with a number, but basically I'm not changing what's inside. I'm never updating it like this. I mean, it's hard to explain why this is a good approach, but basically, instead of having something out here that I would call increment, and in increment, I might, it might be easier to see this if I had it's going to be an actual object. So maybe increment just takes something called counter, and then it does counter.value equals counter.value +1. Again, I'm not really selling it very well, but the functional approach would be more like I would have something called increment, but I would say increment immutable, because that's the big keyword in functional programming. And instead of modifying that counter, I might take that counter, and I'm sure there's a way. Is there a way in JavaScript to, or sorry, in Python to clone something easily? The idea is I want to return a brand new copy of it and only update that copy so that the original thing has been unchanged. That's the big idea in functional programming, just that you don't mutate things. Instead, you use things and you create entire copies out of them, but you never, and then you could change that, but you never change the original. And so you always have this record as time goes on of what it looked like before you did the operation. And as a result, you can kind of build things in a very, it's sort of like a factory where like at each stage, you're sort of like copying it and then doing something to it. And when you're done, you see what it looked like at every intermediate stage. And that's very wasteful in terms of memory, but it makes it really obvious when something goes wrong, where it went wrong. And it's really easy to isolate, oh, the problem's not, one line of code in this 50 line of code thing. The problem's this specific function that does that specific step that takes it from this state to this, slightly different state. Honestly, I bit off more than I could chew trying to talk about it right now with this. But we'll encounter it a lot more in React, because React sort of, like those languages, kind of pushes you in that direction. So we'll see it there, but probably not for a little while.
Gotcha.
All right, cool. Well, I ate up 10 more minutes of your time, although it's still technically my time. But yeah, let's give you guys 20 minutes back. And then what time do we come back again? Showing off more things you should be able to
1:30?
see. So what, actually explain to me, when does lunch start for you guys? Like on my calendar here, would that be 1 p.m. for you guys that you come back? Like you have 2 hours for lunch?
So far, it's been 12 to 1:30 generally, like very generally.
Okay, got it. So you come back like here. This is when you're working. Okay, cool. Yeah, well, that works for me. And I should be sorry that we still haven't, instructors haven't exactly set office hours. But I should be generally available. But with Zainab out, I'm doing a little more like using the afternoon to prepare for tomorrow's lecture and stuff, because normally we like to switch it off a little bit more. But yeah, we are generally going to be available during the assignment time, and certainly the TAs will be available. So yeah, see you all then. And I'll stop recording and I will share it. Python on React sounds interesting. Cool. All right. Take care, y'all. We'll stop recording.